Well, so far the transformations we've talked about have been a horizontal, well, first we did a vertical shift up or down, and then we did the horizontal shift, which transforms a function to the left or to the right. In all of those cases, the shape of the graph didn't change, just its location. Maybe we moved it up and to the left, or we move it down and to the right, perhaps. Well, the last two transformations we're going to look at actually change the shape. What it's going to do is stretch or shrink the graph. And the first one we're going to look at is vertically stretching it, which makes it look taller and thinner, where shrinking it means we're squashing it down to make it shorter. Okay, so let's take f as a function and let c be a positive number. Let's just worry about this first case first. If c is bigger than 1, notice that if c is bigger than 1, if you multiply a number by c, it's going to make it a bigger number. Well, if bigger in a magnitude at least, because it could be a negative number. Okay, so the graph of this function, given that we have this function already, y equals f of x, if you put a constant in front of f of x, that vertically stretches it by multiplying each of its y coordinates by c. Because remember, f of x is just y. And then if c is between 0 and 1, when you multiply a number by that, it is going to shrink it in magnitude. It'll make it smaller in magnitude. So that would be shrinking by the same, multiplying it by c actually makes it a smaller number. Okay, so let's look at an example. Here is our first function, f of x. Is absolute value of x. So the absolute value of x looks like this. All right, well, what does this one look like? G of x, given that we know what f of x looks like. And notice that g of x could be written as 2 times f of x, because f of x is the absolute value of x. So we get 2 times it right here. So it looks just like this. So this is going to vertically stretch it. So let's, even without making a table of x, y values, we don't even need to. All we need to do is, for example, well, let's go ahead and get 0 out of the way. If x is 0, well, 2 times the absolute value of x is 0. So that point they have in common. Well, pick any other point here. On f of x, this is the height. On g of x, we need to double that height, 2 times that height. So whatever that is, we've got to go up that much more. And do it over here as well. You can pick any point you want. Like that right there. So let me do it in a different color. This will be g. G of x. So you can see how it's a taller and thinner graph, because we're doubling it. If we multiplied it by 5, it would be significantly steeper. It would be a much narrower, taller looking graph. All right, so now let's move on to h. In h, we see that the value of c is 1/2. It's between 0 and 1, so we're going to shrink the graph vertically. So notice that h of x is 1/2 times f of x. And once again, if you plug in a 0, you'll get a 0 out, so this point is common. And maybe I'll look at this same point I did before. If f of x, the height of the function here is this, h of x is going to be half of that. And over here, f of x was this height, h of x is going to be half of that. H of x. So So because we knew exactly what this graph looked like, f of x equals absolute value of x, we were able to graph these two functions that are similar to this, just a constant number times the absolute value of x, without having to make a table of x, y values. Transformations of functions. We vertically stretched on the first one, and then for h, we vertically shrunk it. Now let's take a look at horizontally stretching it. So it's going to stretch it out this way or shrink it in that way. Horizontally. All right, so f is a function just like before. C is a positive number. Once again, we have, for the positive case, for the c being greater than 1, if the graph of, I'm just telling you this, how does this graph compare to this graph? If we know what this graph looks like, when you multiply x by c, it's going to be probably the opposite of what you expect. That is going to horizontally shrink it. And if c is between 0 and 1, a fraction, it's going to stretch it. So it seems the opposite of what it should, but it does make sense if you plug the numbers in, you can see. So we know what the graph of f of x squared looks like. F of x equals x squared. Let me be fairly precise on this one. 1, 1, and then 2. It's going to go up 1, 2, 3, 4. 4. So that's our graph of f. Okay, that's the graph of f of x equals x squared. Well, in the next one, we have something similar, only we have c equal to 2 here. And we have c equal to 1/2 here. All right, so c is greater than 1, so it's actually going to squeeze it together. It's going to shrink it horizontally by a factor of 2. So really all we need to do is about 3 points. If we plug in a 0, we still get a 0, as we expect, because this is just going to be a skinnier, taller, you may remember what this is called, a parabola. We'll get into that next chapter. Excuse me. Okay, so when x is a 1, we're not going to get a 1 like we did in f of x, 1 squared. We're going to get 2 squared, so it's going to be a 4. So look how tall and thin this is going to be. And a negative 1 is going to give us that same value. So this is the graph of g. Oops. G of x is that one right there in the middle. The tall, thin one. Sorry about that graph not looking too good there. Okay, taller and skinnier version. Actually, I don't want to say taller and skinnier, even though it is. What we want to think about it is it's horizontally shrunk. So we squeezed it in horizontally. And now the next one, we're going to squeeze it outward horizontally. So h, well, let me first write down what g, let's see how I can write that. I really can't write that in a nice way, other than recognizing that we replaced x with 2x. And here we're replacing x with 1/2 x. So if you plug in a 0, what do you get? Well, h of 0 is going to be a 1/2 times 0 squared, so that's 0. So same point, just like we expected. Now, maybe we'll go out to 2, just to get one more point. What is h of 2? h of 2 is 1/2 times 2 squared, which is 1 squared, which is 1. So the ordered pair would be 2, 1. So 1, 2, 1. So you can see, and if we plugged in a negative 2, we'd get a 1. So you can see it's just going to be a flattened out, or I'm sorry, a horizontally stretched version of our original graph f of x equals x squared.